everyone. My name is Orko Prabhudatto. I am a student of Kojura Government Engineering College in Electronics and Communication Department. Today, we are diving into one of the core topics in signals and systems, classification of signals. We will look at different types, their maths, graphs, and real life relevance, all explained simply and clearly. So let's get started. Signals. Here you can see classification of signals. A signal is a bridge between a source and its destination. It is a mathematical representation of a physical property which carries some information. So now look at the significance. 1. Carry information. Signals are the carriers of information in all communication systems like phone, radio, etc. Basis of system design. All electrical, electronic, and communication systems are designed to process specific types of signals. Understanding signal characteristics helps engineers design system. Like audio amplifiers are designed based on the frequency range of 20 Hz and 20 kHz. The 3. Measurement. Detect and quantify physical quantities like temperature, pressure by converting them into electrical signals for analysis. 4. Technological advancement. Enable innovation like smartphones, radar, medical imaging, and wireless communication. Now, energy transfer. Signals can carry energy as electromagnetic waves, and for all these reasons, signals are very important in our life. Now we are going to discuss about the types of signals. At first, we will discuss types of signals based on continuity. A. Continuous time signals. B. Discrete time signals. A. Continuous time signals. Definition. This signals is defined at every instant of time in the given interval. Here it is denoted by xt, and the example xt is equal to a sine omega t plus phi, where x is equal to signal amplitude, t is equal to time variable, phi is equal to phase, omega is equal to angular frequency. The graph we can see here is a sinusoidal graph. The properties of this type of signals: 1. Time variable is continuous here. 2. It is used in analog system. Now we are going to discuss about discrete time signals. Definition. The signal is defined only at specific distant points in time, actually in the given interval of time. It is denoted by xn. X is equal to signal amplitude, n is equal to integer representing discrete time steps. Example, xn is equal to a sine omega n plus phi, where phi is equal to phase, omega is equal to angular frequency. Here we can see the graph. The graph is absolutely discrete and every point is separated from each other. Now we will discuss about the properties. 1. Here n is discrete and it is used in digital systems. Now we will discuss about the types of signals on the basis of amplitude nature. The first type is analog signal, the second type is digital signal. A. Analog signal. Definition. It is continuous time signal whose amplitude can take infinite values in given interval. It is denoted by xt, and its example xt is equal to a cos 2 pi ft plus phi. A is equal to amplitude, f is equal to frequency, phi is equal to phase. Here we can see the graph of this type of signal. In the output of microphone we can get this type of signal. Now the second type, B, digital signal. Definition: a signal whose amplitude takes only discrete values, often binary, is called digital signal. Here we can see xt is equal to 1 at high level, 0 at low level. Here we can see the graph of this type of signal. You can mainly get it in computer binary data or digital clock readings. Now we will discuss about the types of signals on the basis of symmetry. The first type is even signals, the second type is odd signals. A. Even signals. Definition: a signal that is symmetric about the vertical axis is called even signals. Here x of minus t is equal to xt. Example, xt is equal to cos t. Here we can see the graph of this type of signal. It is using Fourier analysis. You can get it by Fourier analysis. Then odd signals. Definition: the signal that is anti-symmetrical about the axis is called odd signals. Here x is equal to minus t is equal to minus of xt. Example, xt is equal to sin t. Here you can see that the graph is anti-symmetrical. We can get this in signal decomposition. Now we will discuss about the type of signals on the basis of energy and power. A. Energy signal, and B. Power signals. A. Energy signals. Definition: finite total energy, zero average power, which means it has finite total energy and zero average power. The pulse signals are one of the examples of this type of signals. Here E is less than infinity and the average power is totally zero. The total energy, here we can see mod of xt square dt, so that E is equal to limit t tends to infinity integration minus t to t mod of x of t whole square dt. Here we can see the graph of it. It is a typically non-periodic function. Here we can see the power signal. The definition of power signal, you can see that it has finite average power and finite energy, which means the signal's energy is less than infinity, but E tends to infinity, and it has average power. For P is equal to limit of n tends to k, 1 by 2n plus 1 summation of n is equal to minus n to n x of n whole square. And the graph, we can say that it is like this, and here the function xt is equal to a sine omega t. Here the types of signals based on periodicity. First, periodic signal, and B, aperiodic signal. Here in periodic signal we can see that xt is equal to xt plus capital T, where t is equal to time period. Format: xt is equal to x of t plus capital T. So xt is equal to, here you can say 2 pi f t. T is equal to 1 by f, where f is frequency, it is time period. Here we can see that after adding t, the function repeats its value, which means after the summation of time period, the value remains same. Here we can see the graph. It is used in oscillators. Now we will talk about aperiodic signals. Here xn is equal to xn plus n. N here is period, which is an integer. Now xn is equal to, here you can say cos 0.01 pi n. It does not repeat. Here we can see that it doesn't repeat, as it is not we can't get integer. Represents finite length. Represents finite length. Here we can see the graph. Now the types of signals based on determinism. A. Deterministic signal. B. Random signal. A. Deterministic signal. Signals can be detained by mathematical equation. Here you can see that x is equal to 5 cos 10 t multiplied by e to the power minus 0.2 t. It is easier for calculation and analysis. Here you can see the graph of this. Now the random signal. Signals can't be defined by mathematical equation. Example, noise. Not easy for calculation. As it is not easy for calculation, the graph is also not easy to depict here. So thank you for your time to let me discuss about this topic. Thank you everyone.